All right, welcome to CCNA3. We're going to do lab 2.2.13. We are going to start here with the packet tracer open and look at the first instruction. You'll see that there's an addressing table here, which we'll need to be able to determine what networks are participating in OSPF. And we'll be configuring router IDs, configuring the networks for OSPF in a few different ways, and then making sure that networks like our local area networks aren't actively getting sent OSPF messages. And then we'll verify that we did all of that. So let's get started. The first step here is configure the router IDs. And if you're doing this, might not be the most efficient way to get onto each router and do the router IDs first, but it makes sense from a point of view that the router ID will already be set before you're actually using OSPF. Okay, so first we have to get into configuration mode. And then to get into OSPF configuration mode, you do router OSPF, and then you put a process ID. The process ID doesn't really do anything. It's local to the router. So as long as you use the same process ID on the local router, all the configurations will be the same. But for ease of configuration, we're going to use process 10 each time. All right, and so then we need the router ID, and this is router 1. The router ID looks like an IP address, but in fact it is not an IP address. So with that said, we can use whichever we can use whatever IP looking address that we want for the router ID, but they do need to be different. You have to have a unique router ID for each router. Okay, router OSPF. And then the process ID, which we decided is 10, and then router ID, there we go. So all 2s because it's router 2, and that'll just make it easier when it shows up in things like the neighbor table. So we enable, get into global configuration mode, and then we do probably worked anyways. Router OSPF, process ID, and router ID, in this case, router 3, so we just beat the letter 3 a few times. Okay, so this is the way the OSPF routers identify themselves, and the routers will use the router ID to build the topology tables. It talks about using wildcard masks. We'll see that we can get away with not using, without specifying the wildcard mask. If we put in the address of the interface and then all 0s for the wildcard mask, OSPF will find that interface and will use that network and advertise it using OSPF. So we'll see that there's a few different ways that we can do this, but the first way that we're going to do it is the traditional way with the IP address and the wildcard mask. See, it tells us which one. It says configure the routing process in router 1. So we'll do that one first. Makes sense that we'd start with router 1. Hey, that was not what we're after. Let's pop the instructions back up there and topology, and then get on router 1. Okay, so we're already in the OSPF routing process. And if we look at, let's see what it specifically says. Configure the network statements wildcard masks are required to activate the OSP routing on all the attached networks. The network statement value should be the network or subnet address of the configured networks. Okay. So there's different ways that you can configure OSPF. And on this first one, we're going to use the network statements in the router configuration mode, or the OSPF configuration mode. So network, and then help if we had a list of the addresses. So we're going to pull that up right there. And router 1. So the first network is 192.168.10.1, and it's a /24. So the wildcard mask for that is going to be the inverse of the subnet mask. So it's going to be 4 zeros and 255. And then you have to specify an area, and for us, it'll always be area 0. Every OSPF instance has to have an area 0. So if you're only going to have one area, it better be area 0. And then the next network, which is 10.1.1.1. And this is a /30. So since 252 is the last number in a /30, if we subtract that from 55, you end up with 3. Or you just think of it like the first 2 bits, 1 and 2. You add those together and you get 3, which is easier with smaller numbers. Do it that way. And then it's an area 0. And the last one is similarly. Oh, and I do believe that it's okay if we wrote it this way. What you'd want is you'd want the network address there, and I have been writing the interface addresses. So this would be a 0. We'll see what comes up in the configuration, see if it corrects it for us. Otherwise, this one is going to be 10.1.1.4 since yeah, since that's the bit and the network address. And same wildcard mask, area 0. Let's see if this works actually. If we go and we will need to do a passive interface later, so we'll do passive, actually the dash, passive interface, and that's going to be the LAN interface. So on this local area network interface right here, there's no other routers to talk to. So we don't want to send out OSPF packets unless there's another router to talk to. The risk would be that someone hooks up a router to that network and starts messing with your OSPF. So part of this is security, part of this is efficiency, and the passive interface is going to be gigabit Ethernet 0/0/0. Okay, let's see what came up in the running config, because what it should do is correct us. So the interfaces were already configured for us. We didn't have to do that, and it did. Look at that. So we put in the interface address and it corrected it into the network address that we need. It's great. We actually put in the correct network address in there and it used it. So that's the most explicit way for activating an interface with OSPF. That's what we're doing here. We're putting these network statements in. We're saying that any interfaces in this network are participating in OSPF. We're not actually saying advertise this network, which is an important distinction, especially when we start just enabling OSPF on the interface. So we display the running configuration to verify it, and we can compare these networks. Actually, probably better to do the show. Brief. You look at the actual interface configurations. We can see that 192.168.10, 10.1.1.1, and 10.1.1.5, and we have those up here. So great. We're advertising the networks that are attached to our router. And then configure networks for OSPF using the interface IP addresses and quad 0 masks. So here's a second way to configure OSPF. So we did router 1. We're partway done with router 1. It's probably good practice to save it, even though in packet tracer it's not going to matter. If your computer shuts down, simulating the save for the router is not going to help you, and these routers you have to explicitly power them off to get them to power cycle. So there's really no danger, and your configuration is pretty much saved as soon as you type it in. Though the packet tracer exercise isn't saved. Okay. Next up, router 2. So we're looking at this router right here, and it wants us to do it a slightly different way. So we're in the router configuration mode still. It says it wants us to configure OSPF using network commands with the IP addresses of the interface and quad 0 masks. So it's almost enable. And once you start configuring using a process ID, it's important to use the same process ID. Quad 0 masks and syntax of the network command is the same as was used above. So we're configuring the network command in the router configuration mode. There we go, network. So it's going to be helpful to have the network addresses. There we go. We're doing a router 2, so these guys right here. First network, 192.168.20.1. So I know we put the interface addresses in the first time accidentally, but what we're supposed to do is put in the network address. So the network address, in this case, we want to do 168.20.0. But in this case, instead of calculating the wildcard mask, we're just going to put in 0.0.0. And what we're saying there is find the interface with this address and have it participate in OSPF. And as you can see, a lot less brain work with this because we're just putting in the interface address. We don't have to calculate a subnet mask. And voila. Work. So we're already starting to form adjacencies with other routers. 10.1.1.9. Area 0. Okay. And then we're going to have to do this anyways. So we're just going to make the LAN address passive. If we look at our completion rate, when we do the passive interface thing, you can see the completion rate goes up. It's going to be the next, actually, after we do the next router, it's going to ask us to do that. It's just easier to do it right now. All right, so, and then we could go, let's do this for funsies, and then show run. Okay, so there's our interfaces. Here's the router OSPF configuration. And you can see this time when we put in the quad zeros is it kept the interface address. We can compare those interface addresses to the actual interfaces, and that way we can verify the configuration. So yeah, those two addresses. So we, I don't know, obviously doesn't have no IP domain lookup written there, which we kind of expect them to have. All right, well, it'll take a little while for that to resolve unsuccessfully. Router 3 is going to be our next one. All right, and this one, we're doing OSPF configuration the modern way, and the way that it's done with OSPF version 3, which we use for IPv6, is you just go to the interface and say, this interface participates in OSPF. So we're going to want to do every interface, except it looks like we have to go back. So it's not completely, done on the interface like it is in OSPF v3. Looks like we're going to have to go back and do the passive interface in the router configuration mode for router 3. But we'll see that we do this, enable, and then we get into the interface configuration mode instead of the router configuration mode. In this case, we're going to start off with interface gigabit Ethernet 0/0/0. And we do IP OSPF 10 area 0. Okay, so we're saying this interface is going to participate in an OSPF. And then later we'll go back in and get it so that it's a passive interface. If we go here, we can see what the names are a little bit more easily. So 010 and 011. So that's the designation for the interface, and then same command. And the next one is going to be interface serial 011, and that one's also going to participate. Now, if we want to do the passive interface thing, we need to do the IP OSPF 10. You'll notice the same process ID as we used in the interface. Router. I don't know what I'm doing here, I guess. Router OSPF. The show commands are like that. Router OSPF 10. And then we do passive passive interface, just like we did before. Give me Ethernet 000. All right. Was that it? Okay. Supposedly we hit all the wickets. But we should still verify the configuration. So the first thing that we're going to do is show run. And you can see that we've got elements of the OSPF configuration on the interfaces and elements. Okay, that work. Elements that are here in the router configuration mode. So traditionally, this is where all the OSPF configuration is done, but in the more modern OSPF way to do it, or the more modern iOS way to do it, is just to designate the interfaces that you want to participate in OSPF. And that's also the way that you'll do it in version 3 for IPv6. Okay. Another important command is show IP OSPF neighbors. And what that does is it shows you the relationships. So if we look, or it shows you who you're adjacent to or who you're talking OSPF with. So if we look at this, we've very cleverly identified the routers with very easy, very human readable router IDs. So we know that 1.1.1 is router 1, and we're looking at router 3. So we're talking OSPF with router 1 over serial interface 011, which we can hover over there, and it should tell us that's the interface. And then we're also talking with this router ID, 2.2.2.2. There's router 2. And if we look at this, see that it's talking over serial interface 010, and that's right there. So we could make this wider so the table's a little easier to read. There you go. So router 2 over serial interface 010, we're talking to router 1 over serial interface 011. And both of the states are full. That means that we've learned all there is to know from routers 1 and router 2 about all of their networks. And we have a complete view of their networks in our topology table. All right. We can do that with the other routers as well. But let's do the routing table, show IP route. And we'll notice that we have routes that have an O next to them. We're learning through OSPF. And in that way, we know about these remote routes. So even though these networks are participating via OSPF, learning networks that are directly connected to you takes precedence over networks you learn through OSPF. So we credit these ones to being directly connected. So those are serial links. And then the remote networks that are connected to router 1 and to router 2, we learn through OSPF. So 192.168.10.0 is right there. 192.168.20.0 is right there. All right. Use show commands to verify the networks and passive interface configuration of the OSPF process in each router. And if we go to our check results, oh, that's Weird. Okay. There we go. 18 out of 18. There's all of our configurations. So shows us 3 different ways that we can configure OSPF. And we'll probably do one with the distributing default route as well. All right. Talk to you guys later.